Morning, afternoon, evening, whenever you're watching this. Welcome to another edition of Miss Fausta's Algebra 2. This is the last set of notes for this unit, so I'm just going to spend a couple minutes talking about quadratics and application problems, some of the keywords and what they mean in terms of quadratic functions, and then I'm going to spend some time today doing some extra examples of each type of problem. So after, I'll let you know when that's starting, and then in the comments, which will be down there somewhere at the end of all this, like on the YouTube screen, you know, down there, I'll put in the times when each example problem starts so you can skip straight to whatever you're having trouble with. The thing that we want to think about though first when we're using quadratic functions in application problems, usually we're going to have something that's going to give us an h of t or a v of t or an s of t, something like that. And it's going to be something like this. You can see that's sort of our general quadratic formula. 99 times out of 100, our quadratic function applications have to do with time, and that's because motion on Earth, which is affected by gravity, so heights of things, the times are related with a quadratic function. So that's why you'll often see t's. Most of the ones that we'll do in class will have h's and t's, but sometimes they'll be a little bit different. So a, b, and c will just be the different numbers in each problem. So a couple of things that you'll often be asked is to find a maximum or a minimum. And then you would also be asked to find when the max or minimum occurs. So remember, if we're talking about a quadratic, then we're talking about a parabola. If we're talking about a parabola, then the maximum or minimum is always at the vertex. So this is always going to be related to the vertex of the parabola. This when part will be the x-coordinate of the vertex. So if you are in standard form like this, that's where you do negative b over 2a. And get that value. If you were in vertex form instead, which you might be given it in vertex form, remember vertex form would look like this. So if you were in vertex form, so your h of t, then the x-coordinate would be the h from the vertex form. So it's either this h from the vertex form or it's negative b over 2a. And then what the actual value of that maximum or minimum is, that's the y-coordinate of the vertex. So again, to get the y-coordinate, or in this case this h of t, you either plug in this negative b over 2a in your standard form, or you just look at the value of k. If you're in vertex form, the value of k is the y-coordinate. So you're really, when you're looking for those two questions, maximum or minimum, and when it occurs, the when is the x-coordinate, and the value of the maximum or minimum, so what's the maximum height, what's the minimum profit, something like that would be the actual value you get when you plug in this x-coordinate. Because remember, the rest of these are all numbers other than the t's. Okay, so those are the two things that you're often asked. The other thing you're often asked is when something hits the ground. And remember, if you hit the ground, then your h is 0. So if you're looking for when something hits the ground, you're literally just replacing this side of the equation. You replace the whole thing with a 0. So you'd put a 0 in where the h of t is, and you'd solve for t. Either using square roots, using the quadratic formula, using factoring. It depends on the problem, but you can use all those different methods to solve that equation then. Or you might want to know another specific height. So say you want to know a specific height, we'll just call it capital H. So you want to know when the ball is 12 feet off the ground. Well, then you just replace the h of t again with whatever that specific height is. And again, you'll get an equation then, so you'll have a capital H equals this. You'll have a quadratic equation that you can solve. Remember, when you're solving quadratics, you always move that to the other side. But those are the big ideas, maximum and minimum and when it occurs. And again, that's always the vertex. And then when something hits the ground, or when it's at a specific height, or just when this y, or this other side of the equation, is some specific value. And if that's the case, then you replace that and you solve it like you'd solve a quadratic. Okay, so we'll be doing more examples of that in class, but this just helps you think about how the ideas that you've already learned about quadratic functions apply to application problems. And in class, we'll do it with specific problems, so that should be really helpful. I'm going to stop there for now. So if you would like now to continue watching, I'll do some specific examples of different ways of solving quadratics, starting from just having a problem and then looking at what we can do to figure out ways to solve it. Okay, so like I said, you're welcome to keep watching. You don't need to take notes. If you want to take notes, go for it. But I am going to go on now. Okay, so I'm going to do 4 different examples, and I'm just going to take you through the thought process of how you choose a method and then how you solve it. So the first problem is 6x squared plus 3 equals 2x minus 6. So when we look at this example, what you can see first of all is that we have things on both sides of the equal sign. So what we want to do first is we just want to move everything to one side so that we can continue solving this. So I need to subtract 2x and add 6 on both sides. That's going to give me a 0 over here. I like to keep the part in front of my x squared term positive. So that's why I'm moving it that way. You could move it the other way. Nothing to put the 2x with, so that stays. 6 plus 3 is 9, and that's all equal to 0. So at this point, I have my quadratic equation. I have it equal to 0. So what I'm going to do now is I'm going to think about how I might solve it. So hopefully you got this in class. Ms. Faust meant to give it to you. If she didn't yet, she apologizes and we'll give it to you soon. But we're just going to go through this flowchart to help us figure out how to solve this one. So first of all, does the equation have a bx term? So the bx term is this middle part, and it does. It has a negative 2x. So I'm going to follow this. Is there anything in front of x squared? So I look at that equation again. Oh, there's my x squared, and in front of it I see that 6. So I follow this arrow down, and I get to the quadratic formula. So I can see pretty quickly for this problem that that's what I need to solve this. So let me just come back over here. A is 6, B is negative 2, C is 9. So x equals the opposite of b, so the opposite of negative 2 is positive 2, plus or minus the square root of negative 2 squared minus 4 times a, which is 6, times c, which is 9, all over 2a. So just continuing with that, x is 2 plus or minus the square root of 4 minus 4 times 6 times 9. I'm going to have to do that one. I think it's 216. 4 times 6 times 9. Yep, 216 over 2 times 6 is 12. So x is 2 plus or minus the square root of negative 212 over 12. So at that point, I'd think about that 212. The fact that it's negative means that I'm going to need an I in this. And I don't believe 212 is a perfect square. Give me one moment. I was not prepared before I started this, but now I have a calculator. So let's see. If I try and do square root of negative 212, we all know, oh, error. That's when we go, oh, that's right. This is an imaginary number, so we're going to put an I after it when we're done. So we're just going to do the square root of 212, and we get 14.56. So x equals 2 plus or minus 14.56i over 12. At that point in this problem, since this number on top is imaginary, I'm not going to be able to combine it with this real 2 or that real 12, so I can just stop right there. I've used the quadratic formula then, and I have solved it. My two solutions, remember there's 2 always, but this represents 2 because it has a plus or minus in it. So this was an example of using the quadratic formula. This was an example where we had 2 imaginary solutions. And the thing that tells us, we could have seen that earlier, The reason that we have two imaginary solutions is because of this negative 212 right there. So that tells us that it's going, because the discriminant was negative 212. So when the discriminant is negative, we have imaginary solutions. So something to keep in mind as you do these, when you're asked about real and imaginary solutions, that's what you're looking for. Okay, so next example, and if you only wanted to see a quadratic formula example, you can stop now. You can tune in again later to watch the next example, whatever makes you happy. So that was our quadratic formula example. My next example is example 2. And it is 2x squared plus 3 equals negative 125. So I look at that. I can take out this handy flowchart again if I want. Does the equation have a bx term? So I'm going to look at this. I see an x squared. I see a 3. I see a negative 125. I don't see anything with x by itself in it. And that's what this question means. Is there a term with x without it being squared? This problem doesn't have that. So I go to no, and I see I'm going to solve this with square roots. So square roots, remember, is backwards PEMDAS. So let me write square roots over here. So we know that's what we're doing in this one. So PEMDAS in reverse, we get rid of any addition or subtraction first. So I subtract 3 on both sides. 2x squared equals negative 128. Feel free to use a calculator if you need to. I divide by 2 because I'm doing 2 times all that. I get x squared equals, I think it's negative 64, but it's Monday and I haven't had much coffee, so yep, negative 64. Now I need to take the square root of both sides. At this point, right, if we get anxious and we just go straight to typing it in our calculator, we get another one of those error messages. But we remember then that this negative means my answer is going to be imaginary. So I put my I at the end. Square root of 64 is 8. But again, we remember that the calculator doesn't give us positive and negative. So our two answers for this are x equals 8i and x equals negative 8i. And if you want to write that just with the plus or minus in front of it, I shouldn't have left all that space in between the 8 and the I. They're really just multiplied together. And we have an example of solving with square roots. Okay, so let's look at a couple more examples. We've used 2 methods so far. We have 2 left to go. So at this point, you know, if you were paying attention, you could probably use a little process of elimination. But the point of this is to show you how to choose methods as well. So example 3. Try to get that a little bit more clear. Sorry about that. There we go. Example 3, we're going to have x squared plus 12x equals 28. So again, if you have the flowchart, go for it. If you don't have the flowchart, there's other ways you can figure it out. I'm just trying to show you how this can be really helpful. So does it have a bx? Well, I see an x squared, I see a 12x. Aha! I have a bx term. So that would be a yes. Is there anything, a number or a negative sign, in front of x squared? So if I look at this, there's my x squared. I don't see anything in front of that. So that's a no. So my next question for myself is, self, can I think of 2 numbers that multiply to c and add to b? Well, before I do that, I need to get the 0 on one side of this one. So let me just take a minute and subtract 28 on both sides. And I get x squared plus 12x minus 28 equals 0. So now I want to think about whether there's 2 numbers that multiply to negative 28 and add to 12. So when I see that, I think, okay, 28, what is that? 7 and 4? Yeah, 7 and 4 might work. 1 would need to be negative because it's a negative 28, because 7 times 4 is 28. But if I do this, negative 7 plus 4 is not 12. 7 plus negative 4 is also not 12. So I know that 7 and 4 aren't the right pair. 1 and 28 aren't going to be the right pair because they're not going to add to anything near 12. 28, can that divide by 2? Ah, it can. And I get 14. So I either need negative 14 plus 2. Negative 14 plus 2 is negative 12, but I'm looking for positive 12, so I'm going to do negative 2 plus 14. And let me just double check, negative 2 times 14. Yep, so that gives me the negative 28. And just then when I added them, I got the 12. So those are my two numbers. So when I factor this, I write x minus 2 and x plus 14. And now I just have to keep solving this. So x minus 2 is 0, or x plus 14 is 0. Again, remember, these are the factors, but we're not quite done. When we're solving, we want to go all the way to the end and say what x is equal to. So if x minus 2 is 0, we add 2 and we get x equals 2. And if x plus 14 is 0, we subtract 14 and we get, whoops, x equals negative 14. So our two answers are positive 2 and negative 14. And if you ever wanted to check that, you could think about just plugging them back in. 2 squared is 4. 12 times 2 is 24. 4 plus 24 is 28. And you can do the same thing with the negative 14, and you would also see that that works. So this is an example of solving by factoring. And again, the thing to remember about factoring, everybody gets to here, and then once they get here, they get stuck. Well, they don't get stuck, they think they're done, but they're not done. They've got to keep going and get the actual x values. Okay, so that takes us to the end of our third example. One more for you today. So example 4, I have x squared plus 8x equals 9. Again, if you're using process of elimination and you've been watching all these, you already know what method I'm going to use for this one, but just in case, let's go ahead and go through this. Does the equation have a bx term? Yes, there it is. It's 8x. Is there anything, number or a negative sign in front of x squared? Nope, nothing at all. Can I think of two numbers that multiply to c and add to b? Well, if I move the 9 over there, I would get negative 9. Are there any two numbers that would multiply to negative 9 and add to 8? Well, multiply to negative 9. Actually, there are, aren't there? Wait a second, did I pick a bad example? No, I just picked one that we could have done by factoring, right? I wanted to do one by completing the square, but I've actually found one that we can factor. So let's just factor it, because that's quicker. Multiply to negative 9 and add to 8 are x plus 9 and x minus 1, right? Negative 9 plus 1 is 8, or 9 minus 1 is 8. 9 times negative 1 is negative 9. So x is either negative 9 or x is 1. So that ended up being a second factoring example. Oops. Now, I'll do one more. But that just shows you how quickly you can solve it using factoring if you think of those two numbers. You just have to think for a minute. And if you don't find those, then you use another method. So let's do x squared plus, trying to make sure I get one I can't factor now, 10x equals 9. We'll still use the 9. Because I'm pretty sure, yeah, because there's not going to be any numbers that multiply to negative 9 and add to 10. No, there's not. I'm still thinking, no, there's definitely not. So in this case, we get to here. We say is b an even number? In this case, b is an even number because b is 10. So we're going to solve this one by completing the square. This could also be solved by the quadratic formula. If this was not an even number, it would be really easy to do it that way. Actually, all of these can be solved by the quadratic formula, but the quadratic formula is the one that has the most potential mistakes in it. So in order to solve this by completing the square, we look at this 10, and we do 10 divided by 2, and we get 5, and then we square the 5 and get 25. So remember, what we want to do is we want to add the 25 on both sides. So I'm going to add 25 on both sides to keep my equation equal. Over here then, this side factors, because now I know that 2 5s multiply to 25 and 2 5s add to 10. So this becomes x plus 5. This left side of this is called completing the square. So we've done that a few times now. And 9 plus 25 is 34. So now I keep going to solve that one. I take the square root of both sides, and I get x plus 5 equals positive or negative something. Square root of 34, 5.83. So if x plus 5 equals positive 5.83, I'm going to get one thing. If x plus 5 equals negative 5.83, I'm going to get something else. Now I subtract the 5s. Get 0.83 here. And negative 5.83 minus 5 is negative 10.83. So we come up with our two solutions, a positive and a negative. Remember that this is where, when you do the square root, that's when you put in the plus or minus, and then you have to split it into two equations to solve it. So now you've seen one more example of all different types of solving quadratics. Hopefully this has been helpful. Have a wonderful day, Mustangs. Thanks.